Hello students, welcome to the next lecture on the CSI UGC NET examination. Today we will discuss about the statistics question related to the paper December 2018. We will cover the part B and the part C. Myself Dr. Garg. You can simply follow my YouTube channel. The name is Dr. Harish Garg. Else you can simply scan and join my WhatsApp group. What you will be found on my YouTube channel, you can see there is a playlist CSIR UGC NET where you can see the previous year papers related to the December 2016 real analysis, December 2018 real analysis, complex linear algebra, linear PY questions on the partial differential equations from the year 11 to 23, PY question on the differential equations, integral equations, calculus of variations, PY question of the eigenvalue from the year 2009 to 23, and many more. Also, you can see the previous year statistics solution of the year 2022 and many more in this playlist. So let's start with this video. You can simply join with me here. So you can watch till the end. I will tell you the very simple shortcut tricks for each question. Let's say question number 51, which is related to the part B. Only one correct option is there. What is given to you? Consider the linear model yi, where I varies from here. So it means y1 is my theta 1 plus 2 plus epsilon 1. y2 is my this plus epsilon 2. And y of I is my for I is equal to 3 and 4. So it is my theta 1 minus plus epsilon 3, and y4 is here. Now which of the following such that variance of each epsilon I is my sigma square and expected is 0? Which of the following is estimable? How you can check which of the following is estimable? So there are two ways. The first way is you can write the matrix corresponding to this theta 1, 2, 3 and 4, like the 1, 1, 1, 1. This is 1, 1, 0, 0, 0, 0, minus 1, minus 1, and theta 4 is nothing, so here there are the three are. Then you have to take any of the vector a, b, c, d, multiply them, and you can write as a linear combinations of this a, b, c. Then your target is to find the value of the a, b and c from here. But I will tell you the very simple shortcut way. You can think about here. Can you make theta 1 plus theta 3 from here? You can never make, because if I use these two equations, if I subtract them, it will give you a theta 2 plus theta 3, but it is not this is there. Okay, can you make theta 1 and minus theta 2? No, so it is not the right answer. Theta 2 minus theta 3, you can never, if you add them, it will be twice of this. You can see it will be twice of this, but it will never be here. So similarly, this option is not be there. And last for here. Then your target is to find the value of something so that it will comes my here. If you are able to find this value, then this is the right answer. Otherwise, we will look on the other answers. So firstly, how you can make them? So clearly say that if I found y3, y2 minus y3, what will happen? So it will be this plus epsilon 2 minus epsilon 3. Fine. Now you can find the expected value of this. So what is the this is here, so you can write this. What is the expected value of this epsilon 2? This is 0, this is 0. So you can see you have to find this value which corresponding to which is here. So that means this is the right answer of this problem. This is a simple way you can do this. Okay, next one is which of the following is the value of here. So that's again a very simple. You have to find the value of this. Fine. So it's the conditional probability. So you have to write firstly this manner. So the upside is the intersection. How you write the intersection? This is my here. Now if you look at that, what is given to you? X and y are uniformly distributed. So I can write this as a 0, 4. This is my 0, 4. This is my x. This is my y. Fine. Now look at the x is greater than y. So x is equal to y. This is a line corresponding to x is equal to y. This passes through here. This is the point of x is equal to y. What is the line of the x is 2y. This is the line corresponding to x is equal to 2y. What are the coordinate of x is equal to 4, y is my 2. Then corresponding to the first part, that is on the numerator, which lies here. So this is the portion. Fine. This is the portion which we need to find. So if I call this as a 1, 2 and 3. So what is the meaning of that? This is answer of 2. What is the denominator is? X is less than of 2 upon y. So that means this is 1 plus 2. Now how you can find this value? That's very simple. If I write O, A, B, C and D. How you find the area of 2? I can find the area from this triangle OBD minus triangle OCD. How you find the area of triangle? Half base, height is my 4. What is the OCD? Half, base is 2, 4, this is my 2. So what is that? This is a 16, this is 8, this is 4. So this is my 4 over something plus 4. Now how you find the area of the 1? How you can, this is the again triangle. So what is the triangle of this? So half base of this, that is my 8. So this is again 8. So this is 4 over 12, that is nothing but my 1 over 3 is the right answer of this problem. So you can simplify, you can write the diagram of the uniform distribution, find the area of the triangle, rectangle, square, whatever it made in the problem. Okay, now it's a Markov chain. So whenever there is a Markov chain, I will upload this PY question of the Markov chain from the 11 to 23. You can watch them very soon. So firstly, there are the 3 states like 1, 2 and 3, 1, 2 and 3. So I can write 1, 2, 3. 1 to 1, probability 1 by 3. 1 to 2, probability 1 by 3. 1 to 3, probability 1 by 3. 2 to 1, there is a probability of 1 by 2. 2 to 2, there is a probability of 1 by 2 and so on. And 3 to 3 is my 1. Now, what is the irreducible? Is it possible you can start from the 1 and go to 2 and go to the 3, or you can start from the any of the state? Is it possible to can go to any of the other state? Not possible. If you start from the 1, go to 3, then it is not possible to go from 3 to 2. It means this chain is not irreducible. So the first option is cancelled out. What is the recurrent? If you start from the 1, is it possible you can return back to the 1? If you go from the 1 to 2, 2 to 1, that's possible. But if you go from 1 to 3, but there is no way that you can go to 3 to 1 or 3 to 2 and then 2 to 1. So it means this 1 is my transient state. Similarly, is it possible you can go from 2 and come back to the 2? You can go from the 2 to 1 and then again back, that's true. There is no other path you can go from the 2. So it means this is my recurrent state. Is it possible you can go from the 3 and return back to the 3? There is only one path. So that is also be a recurrent. Fine. So but here this said xn, that means all the states are my recurrent, but there is one state which is transient, so this option is also cancelled out. Now look at that. This is the self loop. Always remember, whenever there is a self loop, then the period of each the state is 1. So 2 has also the self loop, 3 has also the self loop. That means this is a periodic. Whenever the period is 1, then we can say is a periodic. Now it is a not irreducible, it means it is a reducible Markov chain. Whenever there is a reducible Markov chain, then it has the infinitely many stationary distribution. But if it has a irreducible and the aperiodic, then it has a unique distribution. But it said it does not admit, that's a wrong statement, because it has infinitely many stationary distribution. What is the meaning of the observing state is, if you look about the diagonal entries, if any of the diagonal entry give you 1, that give you a absorbing state. So look at that, the third, this. So this has absorbing state, yes. Third is my state which is an absorbing state. So the right answer is my D is my correct answer. Okay, which of the following is follow here? So that's again a very simple. X follows the Cauchy distribution of 0, 1. What is the PDF of this? 1 over pi 1 plus x square. Then you have to find the distribution of 1 minus x over 1 plus x. So how you can find the distribution of the y? That's very simple. I can take the value of the x in terms of y and dx over dy. You can see my lecture transformation of the random variable. You can see this formula. Can you find the value of the x from here? X is nothing but my this. So then dx over dy. What is that dx over dy? You can easily see this is nothing but my here. Now you can substitute what is the fx is my here, but x value of the x is my this. I can substitute this value here. So 1 over 1 plus 1 minus y square, 1 plus y square into mode of this. So that is the 2 over 1 plus y whole square. So 1 over pi. If I take the LCM, it will be cancelled out. So it will be the 2 over 1 plus y square, 1 minus y square. So if what will happen if you open this square, so it's a 2 will be cancelled out. It's a 1 plus y square. What is that? This is similar to this. What is the meaning of that? Y again follows the Cauchy distribution of the 0, 1 is the right answer, because this is the PDF of Cauchy distribution. We all know the PDF of the uniform distribution is 1 over 1. Normal distribution is, this is nothing but my z. Exponential, double exponential is my here, but it is not be there. So this is the Cauchy distribution. Okay, if x1, y1, x2, y2 and so on, these are my n observations, independent observations. Rp is the product movements, that's called as the Karl-Pearson correlation coefficient. Rp is called as the Karl-Pearson correlation coefficient. Rs is the rank correlation coefficient. So I think all of you know that how you can find the rank correlation coefficient. This is my 1 over d square m into m square minus 1. Whenever there is non-repeated roots, how you find the value of the Rp? That is a covariance of xy divided by variance of x, variance of y. Now look at the options. Rp is greater than 0 whenever this value, and we all know correlation coefficient lies between -1 to +1. Whenever Rp is greater than equal to 0, Rs is also greater than 0. That is not always true. There are so many examples. So these are standard results. Remember, whenever the Karl-Pearson coefficient is 1, this implies Rs is equal to 1. That's always be the standard results. So is it there? Yes. So that C is the correct option. While converse is need not be true. Converse need not true. So that means this option is not true. Rest options are cancelled out. So C is the right answer of the problem. Okay, given the observations are there which are from the uniform distribution. X follows my uniform distribution from theta of this. Okay, then you have to find the ML. So what is the PDF of this? So 1 over, what is the uniform distribution? 1 over B minus A. This is my 1. So which is independent of this. So you can never define the value of L. So how you can define that? So that means you have to use the ordered statistics. Always remember students, whenever you find the function which is a constant, then you always use the ordered statistics. What is that? The first number is always be less than of this, is second order statistics, and here this is my, and this will be lies between. Fine. Then what your target is to find the estimator of this. So from here, what is the value of this? What is the x1 is? The smallest element. So look at that. What is the smallest element in this observation? So smallest element is my 0.71. So what is the theta 1 is? 0.91. So this option is cancelled out. This option is cancelled out. If you look about here, what is the xn? That is the largest element in the given observation. What is the largest element is? 1.68. So 1.68 is less than of here. So what is the theta from here? Theta is greater than of the 0.88. So this option is cancelled out. Only the right answer is my B. Or you can see if I combine them both, what is the meaning of that? Theta is less than of this and greater than of the 0.88. Which observation satisfied? Only 0.9 is satisfied in this example. Okay, now this is related to the part C. So it has more than one correct options. What is given to you? Xi follows my normal distribution of 0, 1. Fine. Okay, whenever there is a question related to the normal distributions and they are asking to calculate the probability, use always the center limit theorem. Fine. Or you have to convert into the z, that is x minus mu over sigma. For example, if I look at the first option, if I consider this x1 minus x2 minus x3 and so on up to the x10, if I call this as a y, then your target is to find the value of y greater than 0. Then what is the expected value of the y? What is the mean of the xi's? They are 0. So this is 0 minus 0 minus 0. What is the variance of y? Because they are the IID, so the variance is 1 plus 1 plus 1 up to the 1. So it is a 10. So I can write this in terms of the z. What is that? Mu, that is the mean is 0. So that is my here. So what is that? Whenever z is greater than 0, answer is always be half. So the right answer is here. If I look at the second option, if I consider this as a y, x1 minus x2, x3 up to the x of 10. What is the expected value of the y? Expected value of the x1 is 0. What is the product? We all know what is the expected value of this, which is this into this if x and y are independent. But it is given that they are IID. So I can write that expected value of the x2, expected value of x3, expected value of x10. But each of the expected value is my 0. So this is my 0. So again, whenever expected value is 0, so how you can write that this is z greater than 0. Again, half is the right answer. This is also the correct option. Now look at this third option. How you can solve that? This is sine of x. Fine. So now look at that. If I simply, we all know the value of the sine x is less than of the x. So what is the meaning of that? Expected is always be the monotonic function. So I can written this off here for each xi. So what is the expected value of this? 0. So it means expected value of the sine x is less than 0. Fine. Now if you look about this, if I consider this minus of sine of x, this I consider as a y, then your target is to find the value of here. So expected value is less than 0, so we can write this value as expected value, so called as a z, is also be a less than 0. So what is the meaning of that? This is also be a half is the right answer. Look at the last option. So if I just clear this screen. Now fourth option. So we can see that if we look about the first option and the third option, what is the difference between them? That is only between the function sine of this. So what is the meaning of that? If I simply take y is sine x1 minus sine of this, and from the first part we know this value hold. So what is the meaning of that? Sine of x is greater than of this because it's an increasing function. So what is the meaning of that? If I consider this as a y is my greater than 0. If I consider this as my y, so whenever y is greater than 0, the mean is also be here. So we can return this as a 0. So that's again half. So all are my correct answers of this problem. So A, B, C, D are the correct answers. Okay, now look at the next one. Which of the following statement is the hazard rate function? So this is related to the reliability theory. So what is the hazard rate? Denoted by lambda. This is the PDF divided by the CDF. This is the ratio of the PDF divided by the CDF. Now if you look about that, ffx is given to you alpha x plus beta x of this e raised to power minus of this. How you find the CDF? That's very simple. You can integrate from lower limit is my 0, so 0 to x of this function. So clearly says if I take x raised to power alpha of this as a y, so alpha times x minus 1 beta times this minus 1 of dx is my dy. Fine. So what is the meaning of that? This portion of dy is my here. So this portion is nothing but 0 to x e raised to power minus y dy. So that is e raised to power of 0 to x. So what is the x is? My y is my here. So I can return here. When you take 0, it is 1. It is my e raised to power minus of this. Fine. So when you substitute here, what is the value of this? Oh, sorry, it is 1 minus of this. It's a reliability, 1 minus of this. So therefore failure rate is my PDF over 1 minus f. So f is my here. When you take 1 minus of this, so it will be e raised to power this. So it will be cancelled out. So the answer will be alpha x raised to power alpha minus 1 beta x raised to power of this. Fine. Now you can make your answers here. So I can write for you here. Now you can see whether this is my hazard rate, whether this is an increasing function. For some choices, yes, you can easily take, if I take alpha is greater than 1, beta is my greater than 1, then definitely this is my increasing function. Fine. So this option is correct. What about the other? Can it be the decreasing function? Can you say it's a decreasing function? Yes, you can say whenever you take alpha is less than 1, beta is less than 1, so it will be my 1 over something are there. So it is a decreasing function. Is it a constant function? Yes, you can say if you take alpha is 1, beta is 1, so this value will be 0, this value will anything power 0, 1, this is 1, so it will be alpha plus beta, that's a constant. What is a non-monotonic? Non-monotonic means it can either increase or it can either decrease. That's a very simple. If I take alpha is 2 and beta is say it's a positive and it's a negative, so I can take beta is any number less than 1, say half. So what is the function is 2x plus beta is my half of this. Then you can take the derivative minus x raised to power 3 by 2. So clearly says that whenever x you can take as a 4, so clearly say that critical point will be, if you find the critical point, it will be 1 by 4 is x raised to power 3 by 2, or x will be 1 by here. Fine. Sorry. So this 1 by 4 raised to power 2 by 3. When you take x is greater than of this, so sometimes this number is less than 0. Whenever you take this is a greater than 0, or because x is my greater than 0, so you can take any of the value. Say if I take x is my 1, so this number, when you take x is my 1, so what is the value of this? This value is my positive. When you take x is my 1 by 7, so it will be upside, so it will be less than of the 0, so and so on. Or you can take higher number, it will be less than. So this is also the correct. Again, all are my correct options of this problem. Okay, next one is if xi follows uniform distribution over 0, 2. Fine. Then what is the mn? Mn is nothing but my x of n. That is the maximum of this for the positivity. Then which of the following statement is correct? That's very simple again. If I call this number as a y, that is y is my x of n. Then we all know how you can find the PDF of the y. That is nothing but f PDF of the this of CDF of this, say x of power n minus 1. Now what is given to you? Xi is my uniform distribution. So what is the PDF? 1 over b minus a. What is the CDF? X minus a over b minus a, x over 2. So I can substitute here. What is that? This is n. PDF is my 1 over 2. CDF is my x over 2. So I can write in terms of the y, it's y over 2 n minus 1. So I can write n by 2 y over 2 raised to power n minus 1. Fine. So this is my PDF. Now look at this is the PDF of y, that is a m of n. Now the first option, mn converges to 2 almost surely. When it will be convergent? So whenever there is a condition of the almost surely, you have to find expected value of the mn. If it converges to the 2, then we can say this converges to the surely. So PDF of this, so how you can find the expected value of the y? This is y of PDF, n by 2, y raised to power n minus 1, 2 raised to power n minus 1 of this. Fine. Now how you can take the limit? This is a 0 to 2. So n is outside, 2 raised to power n is outside. So integration of this is y raised to power n. So it is n plus 1 over n plus 1 from 0 to 2. So what is that? It is n over n plus 1. So it is my 2. 0 will be 0. Now it goes to the 2 as n goes to the infinity. So that means expected value of y, if I take this is a y, will goes to the 2 almost surely as n approaches this. So this is a correct state. This is a correct state. Fine. So it means Mn convergence to the 2 almost sure. How you can check whether it's a convergence to the probability of the distribution? So as I discussed in the many times, look at this remark. If it is convergence almost surely, it implies convergence in the probability. So this is the correct option. So this is also the correct option. Once it's a convergence in probability, it implies convergence in the distribution is also the right answer. How you can check the last option? So it converges to the normal distribution. So how you can check that? You can check expected value of this goes to the 0. Variance of this is my positive. That's the meaning of this. Now firstly we can check the expected value. So 1 by root n is outside. Expected value of the Mn is my 2. So it is 2 minus 2 is my 0. So first condition satisfied. How you can find the variance? So 1 by n is outside. So variance of Mn minus variance of 2 is my 0. How you find the variance of the Mn? So I can written this as, if I call it this as a y, so e of y square minus e of y whole square. Fine. So how you can find the expected value of the y square? So this is my PDF of the y. So how you can write? I can find the expected value of the y square here. So this is 0 to 2 y square of this. So n over 2 y raised to power n minus 1, 2 raised to power n minus 1. So n over 2 raised to power n outside, it is n plus 1. So n plus 2 over n plus 2 of this. So what is that? This is 2 raised to power n cancel. It's a 4n over n plus 2. So I can written as a 4n over n plus 2. It is, what is the expected value of the y? This is my 2n over n plus 1. So it is 4n square over n plus 1 whole square. Now it will be as n approaches infinity. So this part, because it's a n, this part will goes to the constant. So this is a constant, this is a 0. But we need a greater than 0. So which is not greater than 0, it means this option is cancelled out. So the right answer is A, B, C are my correct answers of this problem. Okay, look at this question number 114. So again, x's are my given to you as normal distribution. Then your target is to find the xi square. So we all know whenever x follows the normal distribution, what is the square of this x1 or xi square? It follows the chi-square distribution. Fine. Or you can say if x1 follows the normal distribution of 0, 1, then x1 square, I can written this x1 as x1 minus 0 over variance. Fine. So this is follows my chi-square distribution with the degree of freedom 1. So it means how you can find the Sn. This is a chi-square, this is a chi-square, this is a chi-square, and by using the additive property of chi-square, if x is chi-square, y is chi-square, then the addition of them is also the chi-square. So it means the summation of this will also follow the chi-square, but the degree of freedom is my n, because there are the n variables. So it means what is the expected value of the Sn? Once you have the chi-square, expected value is n, variance is my 2n. Now look at that. The first option, you can write this in terms of the z, this minus Sn divided by square root of the variance of Sn. It follows the normal distribution 0, 1. But you can write what is the variance of this? Root of 2n, but it is only that 2. That will give you over 2n. This is a n, but it is not there, so this option is cancelled out. Look at the second option. So this is an inequality, so we can apply the Chebyshev inequality here. So what is the Chebyshev inequality? X minus mu is greater than epsilon is always be less than or equal to variance of x divided by epsilon square. So what is that? This mu is the mean of this x. So we will find the mean of Sn over n. So what is that? It is 1 by n is outside. What is the mean of the Sn? Is n. So n over n is 1. But here is a 2. So which is not mean. So it means Chebyshev inequality is not, so it can never be converged. So it is wrong answer. Look at the third option. It converges to the probability 1. That's a Chebyshev inequality. So we find that is 1. What is the variance of this? It is 1 over n square. Variance of Sn. Variance of Sn is my 2n. So it's a 2 over n. It converges to the 0. So once it will be the 0, so therefore this Sn over n converges to the 1 with probability 1. That is, by using the Chebyshev inequality, this is the correct answer. Look at the last option. So we can find this value. I can write here. So what is that? I can return this number Sn minus this. I can write this simply. There is no problem. But here we need the 2n. So I can multiply by 2 and divide it by 2 also. So if I consider this as a y or z is less than of x, this is divided, I can take as here. Now if you compare them, it will converges to the y less than of the x when y will follows this behavior, and y is my here. So what is the expected value of the y? This is root 2. Expected value of the z. Expected value of the z is 0, so it will be here. What is the variance of the y? I can written as a square of variance y. What is the variance? Y is my 1. Variance of the z is my 1, so it is my 2. So that's a 0, 2. So it is a right answer. So C and D are my correct answer of this problem. Okay, look at this again. This is the Markov chain. So Xn is a Markov chain with a state space S. Pij is the nth step probability. Di is the period of this. Then okay, so you just remember the first tips for you. If you remember, that could be easy for you. So whenever this is my here, that's a commute, and for the any of the other ij, kl, this j and this j must be same, then this implies period of this I and the period of this j is correct, but converse need not be true. Converse need not true. Okay, so if you remember these tips, then clearly say that this is the right answer. But if you not remember, then what you can do, you can think about the counter example. If I think about these two pairs, two state whose period is same, so I can simply consider this as a self loop. 1, 1. What is my p is 2 state, 1, 1 here. Fine. Then the Pij of n. So what is the p of n? This is nothing but the identity. So what is the identity of power n? This is again the same. Now what is the Pij? If I consider I is my 2, j is my 1. So what is the 2, 1 of here? This is 0, which is not greater than of 0. So this option is cancelled. Look at the second example. So if again you can see here, if period is same, as n approaches infinity, again it is not 0. So here again this option, this example, if I consider for this again, then the p21 of n is my 0, which is not greater than of 0. Second option is also cancelled out. Look about this one, when the limiting value is my 0, but implies the periods are my same. So we can take the counter example reverse. I can consider this as a 1, this as a 0. That means 1, 2. Fine. This is the meaning of this. Fine. Now if I take p raised to power n, this is not be there. I want a period to be the same. If I consider this as a 0, this as a 1, 1. What is the meaning of that? This is my p. What is the p raised to power n? This is again same. Fine. If you multiply them, it will give you again same. So what is the period? What is the diagram of this? 1. It is a 1 to 2 and here. Fine. So period, each element, if I take 2 and 1 limiting value. Okay. So what is the period of the 1? So it is a 1, 2 step, but the period of the 2 is my 1, which is not same. So this option is also cancelled out. So the right answer is my here. Otherwise you can simply remember these tips. Otherwise you can simply take the I is the one of the most common example. You can take them and you can get the result. Okay, this is one more counter example of the Markov chain. You can draw the states. One, whenever there is a Markov chain, you can draw the state diagram. So 1 2 2 1 2 2, this is my 1 2 and 3. Okay, 2 to 2 is a self loop, 2 to 3 is also be there, 3 to 1, 3 to 3 and 3 to 2. Okay, they are talking about the limiting. Okay, that's they are not talking about the irreducible over here. But if you want to check whether it's irreducible, is it irreducible? What is the meaning? If you start from the 1, can you reach back to the 1 again? So there is a one way you can go from here, 1 to 2, 2 to 3, 3 to 1. That's possible. If you start from the 2, can you reach back? 2 to 3, 3 to 1, 1 to 2. Yes, it's irreducible. It has a self loop. It has a self loop, so it means the period of each state is my 1. So it means it is a aperiodic. So it is a irreducible, it is a aperiodic, it means it has a unique stationary distribution. But they are talking about the limiting distribution. Fine. But since it is limiting distribution, but since it is a irreducible, it is a aperiodic, so the stationary distribution is a limiting distribution. Now how you can find that? That's a very simple target. I will tell you one more simple remark. 0, limiting distribution is 0 only whenever whatever the index you have written here is my transient. If you prove that I is my transient, then this is the right answer. Otherwise this is the wrong answer. What is the meaning of the transient is, if you start from the 1, that is I, that is if I say Pij of n, limit n approaches infinity is my 0, then this j is called as the transient state. What is the meaning of that? If you start from the, in this case 1, if you start from a 1 but you are unable to reach at the 1 again, but that is not true. If you go from the 1 to 2, then 2 to 1 and then 2 to 3 and then 3 to 1, it is possible. Is there any existence path? No. It means the 3 is my recurrent state, 1 is also the recurrent state, 2 is also the recurrent state. So none of the transient states, so this probability can never be 0. Fine. Okay, now come back to this question. So what they want to ask you, they are asking that you have to find the stationary probability. That's a very simple shortcut tip for you. You can find the stationary probability P minus I transpose. You can solve this, you will get the stationary probability. So what is the P is here? If I subtract identity matrix, the first value is 0. Transpose, so I can written like of this manner. This value is my 1 by 2, is minus half, and it is 1 by 3. Third value is 0, is half, it's minus of 2 by 3, is my 0. So always remember the sum of the probability 1, so you can always use any of the two row. I can simply use the first 2 row. I can simply add them, so it will be minus 1, it will be 0, it is minus half, it is, if I add them, 2 by 3. Fine. So if I call this is V1, V2, V3, the first equation will be V1 over 2 is my V3 over 3. Second equation will give you V2 over 2 and 2V3 over 3. Now from here you can easily get the value of the V1, V2, V3. So what is a V1? So you can see V3 over 3. So I can written this number as 4 here. So V1 over 2, V2 over 3, V3 and V2 over 4. So what is the value of the V1? 2. What is the sum is? 9. V2, 4 over 9. V3, 3 over 9. So V1, look at the V1. It's a 2 over 9, satisfied. V1, 0, wrong. V2, 2 will be 4 over 9, but it's a 1 by 3, is a cancel out. It's a 3. 3 will be 3 by 9, that's 1 by 3 is the right answer. So A and D are the correct answer of this problem. Okay, look at this another one. That's a sufficient, maximum likelihood, and here. What is the tips for you? How you can check the sufficient? You can define the likelihood function here. That is a L, product of the fx size. And if you are able to write this f as the product of the two function of this is my independent of theta, and this is a function of the x and theta both, then this capital T, which is a function of the x, is called as the sufficient estimator of theta. Fine. And once this is a sufficient estimator, so you can see that if you define the L, product of the fxi, I varies from here, what is that? It is 1 by theta raised to power n. This is product of xi's, I can written like here. So I can also break this component 1 by, and this is 1 over product of x. So clearly says that this function is independent of theta. So this is my h of x and this is my g of here. So which function is the, which part is x function of the x? This part, that is capital T, is my sufficient estimator of theta. So it means the first option is correct one. Now they are also talking about the second one. So what is the remark? What is the tips for you? If you define any of the function which is a 1, 1, then f of t is also sufficient estimator of theta. Meaning, if I simply take f is my e raised to power x, clearly say that e raised to power x is 1, 1. So if I prove that, already I proved this is the sufficient estimator. So it means this is also sufficient estimator. If I prove that x square, which is not a 1, 1, so it is then this is not sufficient estimator. If I simply take log of x is also 1, 1, so it means log of product xi is also sufficient estimator. Now if you look about that, this is the function of the log, so it is a log. So if I simply say log of product xi is also sufficient estimator, so what is the meaning of that? I can return this as some log, and this is of this, and 1 by n is a constant value, so it is also with a sufficient estimate. Or you can say, if I define the function as minus, or you can say minus log x over n, which is a 1, 1, so it means this is my here. Or you can say any of the function which is of the 1, 1. If I say 1 by x, so x is non-zero. Okay, so clearly say this is also the 1, 1, so 1 over this is also the sufficient estimator. So in this example they are asking about here, but sometimes they may ask about the e raised to power of this or any of the function r. Second is they are talking about the log maximum LE. How you can find the MLE? I can rub this screen for here. Okay, so how you can define? I already defined the value of the L. This product of x size of this. Now I can take the log, so this is minus n log of this plus 1 by theta minus 1 of log of product x size. Now you can take the partial derivative theta, which is 0, so minus n over this, it is minus 1 over this, and log of here, which is 0, so 1 theta will be cancelled out, so this will be my minus 1 over n log of this. So this log I can return this number as summation log of xy. So this is my maximum likelihood here. Again I will give you a tips for you here. So in this case this is given to you. If you prove that any of the function which is on to, if you take any of the function which is on to, then g of this is also the MLE. Remember, for the sufficient estimator we need a 1, 1, but if you are talking about sorry, it is not a, this is for the consistent estimator. If you want to prove that consistent estimator, every MLE, this is MLE, so every MLE is also the consistent estimator. And if you want to prove that if you take any of the onto function, then g of this is also be a consistent estimator. But converse is not true. So that is also, so this option is cancelled out. So right answer is A, B and D are my correct answers. Okay, look at this one. So that's a very simple question about that. That's related to the most powerful test are there. What is the tips for you? You have to find the H1 over H0 which is greater than of 1. Then it is most powerful test, otherwise not. What is h1 is? H1 is a null. This is my h0 corresponding to this, and this is 1. So if I found here h1 over h0, so it is my 4, this is my 2 over 3, this is my 2 over 3, this is my 4. Fine. So which one is greater than 1? Here and here. So look at the options. X is equal to 2 here is the most powerful test. When it will be the most powerful? When this ratio will be greater than 1. So 4 is greater than 1. Yes, this is the right answer. The test critical region minus of 2. This is minus 2 is the most powerful test. What is the most value is again greater than 1? Yes, it's also the correct answer. X is equal to minus 1. But 2 by 3 is not greater than 1. So it is not most powerful test. And they are also asking the same thing. It is not a most powerful. Is the right answer. X is equal to 1. Again 2 by 3 is not greater than 1. So it is not a most powerful test. Again they are asking the same thing. Not most powerful. So they are the correct answer. So the right answers are my A, B, C and D are the right answers. Remember, whenever you are trying to do for the CSIR statistics, one question from the most powerful test, one question from the likelihood functions, and two questions from the Markov chain definitely asked in the examination, and you can check very easily in your examinations. Very soon I will upload my lecture on the PY questions on the Markov chain from the year 2011 to 2023 soon after this video. Till then you can simply like, share and comment, and you can simply follow my YouTube channel for finding the more various videos. I hope you can learn something, you can share with others. Best of luck students. Happy learning.